Assalamualaikum, dear students of 4th year class. I am here with applied chemistry. I am going to discuss a new metallurgy. In my last lecture, I have discussed two metallurgies, extraction of iron and the extraction of copper. Now, the last extraction that is the aluminium extraction. What is the aluminium extraction and how do we get this aluminium extracted? How do we get the aluminium in the purest form? I know in my last lectures I have already explained how do you extract the metal in the purest form. First of all, one thing that is very important is its ores. Its ores from which we have to extract the metal. Which one ore is used for the extraction of aluminium? In this case, for example, here aluminium ore that is called as the bauxite. What is the formula of bauxite? Al2O3 N water molecules. Number of water molecules. Which procedure is followed? Before going to procedure, I am going to tell you the steps. First step is the concentration. First step is concentration of ore. Second step is to get the alumina from bauxite ore. Number 3, to get the aluminium in the purest form that will be 90% pure. So we are going to get to be electrolyzed again. That is the Hobbs process, in which we will get the aluminium in the purest form, 99.99%, almost 100% aluminium in the purest form. So this is the basic procedure. You can say it's flow sheet diagram. What is the flow sheet diagram? What one? Concentration of ore. Number 2, getting alumina. Number 3, alumina in the 90% pure form, and last one is the aluminium metal in the 100% purest form. So what are the basic procedure we are going to proceed? Number 1 step, that is the slide concentration of ore. In my last lecture, in the concentration of ore, which method is used? Gravity separator and hydraulic washing. Here bauxite, aluminium ore is to be washed with the help of hydraulic washing. How do we do the hydraulic washing? Just we are going to pass the high speed water on the bauxite ore. So clay and the sand dissolved in the water and washed away, and the aluminium metal, being a heavy metal, sinks down, settled down. This is the way to get to wash over bauxite ore. Second is the gravity separator. Again, magnet is applied over aluminium metal, get attracted with the magnet, and all the impurities is washed away. So we have concentrated over bauxite ore with the help of gravity separator and with the help of hydraulic washing. Next steps. Following steps, after the concentration of ore, we are going to follow the Beer's process, Hall's process, and the Hobbs process. What is the Beer's process? The grinded, powdered, washed, and the, try to understand, grinded and the powdered ore is concentrated by the gravity separator and by the hydraulic washing. It is going to apply the Beer's process. What is the Beer's process? It is on the name of chemist Beer's. So how do we do? In this step, we are going to take the concentrated bauxite ore, and this bauxite ore is heated with the sodium hydroxide at the temperature of 150 to 200 degrees Celsius. So what happened when you are going to react over bauxite ore with the sodium hydroxide? My dears, look at this equation, which is the formula of bauxite ore, Al2O3 with the N number of water molecules. It's reacted with the sodium hydroxide and form the sodium aluminate, and the excess of water is evaporated. This sodium aluminate. So, aluminium oxide with sodium hydroxide form the sodium aluminate. When you are gaining the washing to sodium aluminate, what happened? Sodium aluminate converted back into the sodium hydroxide, and white colored precipitate of aluminium trihydroxide is settled down. Okay, again I am going to tell you what happened when alumina bauxite ore reacts with the sodium hydroxide, form the sodium aluminate. When we are going a strong washing to the sodium aluminate, it is converted back to sodium hydroxide, and excess of aluminium trihydroxide is settled, is synced as a white precipitate. Now, crystals of aluminium hydroxide again washed and undergo the calcination. Calcination means heated it. When the aluminium hydroxide is heated, alumina is formed and water is evaporated. So, first step, concentration. Second step, trying to get the alumina from the bauxite ore. So, by applying the Bayer's process, we have got this Al2O3 alumina with the help of the Bayer's process. This is the second step you have done. Now go the next one. After getting the alumina, third step is to get the alumina, to get the aluminium metal in the form of, next step is the trying to get the aluminium in the purest form. We are going to apply the Haas electrolytic process. What is the Haas electrolytic process? Before going to diagram, I am telling something about the Haas electrolytic process. In the Haas electrolytic process, we are going to add the mixture of aluminium oxide, that is called alumina, with the cryolite, and Na3 AlF6, this is the ore, that is called as the cryolite, and calcium fluoride, that is called the fluorspar. Why do you mix the alumina with these two ingredients, calcium fluoride and sodium aluminium fluoride? The question is very easy. When you are going to heat the alumina, we need the 2200 degree temperature. So to lower the temperature, we add the aluminium oxide with the calcium fluoride and sodium aluminium fluoride. So it's not only lowers the temperature of this mixture, but also it increase the conduction of electricity, ability to conduct the electricity. So why here are the three aluminium positive ions: aluminium, calcium, and sodium. Look at this, my dear. Three ions are present there: aluminium, calcium, and the sodium. That are the positive ions. Now the question arises, if you are going to do the aluminium, you are going to reduce the aluminium, why the calcium positive ion and sodium positive ion are not reduced by the electrolytic process or by the reduction process? Answer is very easy, my dears. In the electrochemical series, aluminium is placed in the lowest place. So that's why aluminium is reduced first, then calcium and sodium. So the problem is solved. Now I'm going to do the reaction processes. What happened? We have to take the aluminium oxide with the mixture of cryolite and calcium fluoride as a mixture. Now next come to the diagram. Here is the electrolytic Hall's process. This is the tank of steel tank. Inner lining in black color is the carbon lining. Try to understand, this is the carbon lining, and the mixture of alumina, cryolite, calcium fluoride is placed in a blue form, is placed here, and these three rods are graphite rods. Now these graphite rods are called as the anode, and this carbon lined and this whole carbon lining in black color act as a cathode. So what happened? These three rods are acting as an anode, carbon anodes, and these inner side of this tank act as a cathode, and mixture as electrolyte is placed here. This is all about. Now come back my slide. So carbon lining act as a cathode, and graphite rods act as an anode. When electricity is passed through them, what happened? Now they come to the reaction. before come to the reaction. And when the negative terminal is attached with the cathode carbon lining and positive terminal is attached with the graphite rod, electrolysis starting, pass of current starts. And what happened at the cathode? At the cathode, aluminium in the form of the aluminium plus 3 ion reached at the cathode, got the 3 electrons and get reduces as a aluminium in the purest form. 90% aluminium is in the pure form. We have to get with the help of the Hall's process. But something happened at the anode. I know carbon linings at the anode, graphites or a carbon, they react with the oxygen, form the carbon monoxide, and carbon dioxide is evolved from the anode. So with the help of anode process, with the help of Hall's process, this is also sufficient if you are going to take the aluminium in the 90% pure form. So you can not apply, there is no need of applying further the Hall's process, but we need aluminium in the 100% purest form. So we have to apply another electrolysis for getting the aluminium in the 100% purest form. How do we get in the mixture? How do we get, what happened? This is the diagram. This is another electrolytic cell, Hope's electrolysis. What happened? There is again 4 graphite ports and carbon lining. This one is the carbon line. Now something is different from the Hall's process. Here you can say this is the inverse of Hall's process. Here these graphite rods are attached with the negative terminal of the battery and act as a cathode, and this lining attached with the positive terminal of the battery and called as the anode. So this is the inverse of Hall's electrolysis process. Electrolytic cell is the same, but difference is that these rods act as a cathode and these lining of the carbon act as an anode. Again, mixture alumina got from the Hall's process and with the cryolite is filled here. What happened? What are the reaction beside this at the anode, at the cathode? Here first of all at the anode, right? Here at the anode, what happened? The anode, look at this. At the anode, this is the carbon lining. At the anode, what happened? Aluminium that got from the Hall's process is in the purest form, which undergo the oxidation, release 3 electrons and come into the aluminium plus 3 ions. Look at this. I'm saying right. At the anode, in the lowest place, aluminium. What happened to aluminium? That aluminium get 90% pure aluminium that got from the Hall's process. It is present in the reused form. They undergo the oxidation, release 3 electrons and comes in the form of the aluminium plus 3 ions. Now this aluminium plus 3 ions is placed at this place at the bottom of this tank, and these aluminium plus 3 ions move towards the cathode rods, these 4 rods. Now when they come, look at this, when they come at the cathode, what happened? This aluminium plus 3 ions, when reached at the cathode, they got the 3 electrons and molten aluminium is collected there. So now you are going to understand the reason of inverse of these terminals. So here alumina is in the aluminium pure form that is getting from the Hall's process, and this is the pure aluminium. This is the pure aluminium. This pure aluminium at the base converted into the aluminium ions, and these aluminium moves towards the rods, graphite rods, where it collected, it got 3 electrons and reduced the aluminium. This aluminium which we have to get with the help of the Haas process is 99.99% pure. You can say this is 100% pure aluminium. This is all about the aluminium